The last amino acid on the list is tryptophan. Just try to get it. So tryptophan, it's aromatic, and I'll draw it in a second, but it's kind of in the middle, not hydrophobic, not hydrophilic, which is kind of odd based on the shape, and you'll see that later. So here's the alpha carbon and carboxyl group attached to that, and amino group, amine group. And tryptophan will have this kind of carbon here separating the aromatic part of the side chain. Then out here you'll have kind of a benzene ring. I think there's one more carbon missing. Yep, maybe like that. So there's kind of like this, sorry, kind of like a second smaller ring, something like that. And sorry, there's a double bond here. So, and then yeah, there should be a hydrogen attached to that nitrogen. So let me just show how they draw it here. It should be equivalent. Here's your alpha carbon. Alpha carbon, amine group, carboxyl group. Then here's the kind of like the carbon I think of as separating this part of the side chain from the protein backbone, little spacing. And then you have this benzene ring with a smaller loop attached to it with the nitrogen here, with the single bonds to the nitrogen. So there's the hydrogen on that. So here you can see it down at the bottom. Tryptophan, hydrophobic. I'm not really sure if it is exactly hydrophobic, because we just saw that this negative number would mean slightly hydrophilic. But just looking at it, it would look like it's hydrophobic. And it's the least abundant on the list on the previous page, but it's also the least abundant, at least for eukaryotes. So here's tryptophan. This is sorted by eukaryotes, and it's the least abundant in eukaryotes and in humans. And then in bacteria, cysteine is a little bit less abundant, and in archaea, it's basically a tie between cysteine and tryptophan for kind of like that 1% of amino acids and proteins. And I think I guess one interpretation of being a rare amino acid is that it's maybe more powerful, it's noticeable when it's used, and needs to be kind of used sparingly. It is kind of a larger, slightly different looking side chain compared to the rest of them, as far as area that it takes up. So TRP and W are the symbols, and we already used T for threonine, and TRY would be too similar to TYR, plus tryptophan sounds phonetically like a TRP. The name tryptophan comes from a couple of Greek words, one meaning like to bring to light, to show. That's the fan part of it, and then the trip part of it is like to rub, and it's presumably from the discovery of it when they were rubbing a pancreas with glycerin. So you see rub, tripsimo, something like that, trips, prefix, and then anime is kind of the fan, tryptophan part of it. It only has a single codon, and only methionine is the only other amino acid to have a single codon. So there's methionine here, and tryptophan here is being the only kind of, like I said, rare amino acids. So just like the probability of getting it from some random nucleotide sequence is the least probable out of all the amino acids except for methionine. It's an essential amino acid, so you do need it in your diet. Something else. I guess, oh yeah. So you can use tryptophan, your body can use tryptophan to create serotonin, melatonin, and a few other things. Niacin is vitamin B3. So you can kind of see how it wouldn't be too far to go from this tryptophan molecule to something like serotonin or melatonin. And then niacin is vitamin B3. It's a few more modifications to get there, but your body can create vitamin B3 from, maybe not your body. It says here essential, but some metabolic pathway can create vitamin B3 from tryptophan.